16-bit timer. So we want to write a program to generate the square wave of 50 hertz. Okay, so square wave means you have a on and off. So 50 hertz, that means you have a 50 cycle. What is the period of the square wave? They are not mentioned, but they given the frequency. So from this I can find what is the period. That is inverse of frequency is time period. We can calculate. Okay, so another thing is on pin 2.3, that means, so in the port 2 you have a 8 pins, right? So 0 1 2 3 4, so that is 2.0 2.1 2.2 2.3. so in 2.3 I want to generate the square wave in the 2.3. Okay, that is the question. Okay, so we will proceed to the solution. First we will find what is the period of the square wave. The period of the square wave is 20 milliseconds. This is both on and off, but I need to find for on and off separately. That means I want to divide by 2. So for on will be 10 milliseconds, for off will be 10 milliseconds. Here I have considered equal, because in the question they said only square wave. They didn't say like it is equal or not equal. So if it didn't mention anything, you can take it as a equal. That means on time and off time both are equal. So we have find that the period of square wave is 20. So then we have divided by 2, so that we find that the higher or lower portion of the square wave is 10 milliseconds. Clear? Now I want to find how many number of pulses you required for the given logic. So the 10 milliseconds, that is the portion of the square wave, that is a 10 milliseconds divided by 1.085 microseconds. So 1.085 microseconds is a machine cycle time. So if you divide by 10 milliseconds by 1.085 microseconds, you will get 9216 pulses. Okay, so this is a pulse you require. So what is the maximum pulse in the 16-bit timer? So you can find, go up to 2 power 16. So 2 power 16 is 65535 exactly. So plus 1 I am adding, because when you start to count, it will go from 0 0 to FF. When it comes to the maximum count, it will reach the roll off condition. So it will take one count. Okay, to include that situation only I am adding plus 1. So when you are writing the program, you can take the standard, this is a final value of 65536 minus number of pulses you obtained. So 65536 minus 9216, you get 56320. So if you convert this into hexadecimal, this is a decimal, right? So if you convert it to hexadecimal, so that means just you want to divide 56320 by 16. So you will get the value of DC00H. Now I want to load this value in the timer register. So this will be loaded in the lower, and this will be loaded in the higher. So that is 00 is loaded in the TL1 and DC is loaded in the TH1. So one defines we are using the timer 1. So TH1 and TL1. So suppose if you are writing program for timer 0, I can write like a TH0 and TL0. Okay, so now we will proceed to the program. So we know that we are writing the program of timer 1 and mode 1. How it was, how we find that timer 1 mode 1. So first we need to specify in the program. So move tmod, first instruction is move tmod comma hash 10h. So this is in hexadecimal. If you write in bit, so I will write 0 0 0 1 0 0 0 0. That means this 0, the hexadecimal, this 1. So this is a T mod register. So to find the what type of mode you are using for your program. So this is your timer 0. See, this is your timer 0. This is your timer 1 bits. So no bits is enabled here. So that means I am not using timer 0. Here this bit is enabled. That means I am using timer 1. Which mode you want to find? So we know that you have a 4 mode: 0 0 0 1 1 0 1 1. So if it is 0 0, you will be using mode 0. If it is 0 1, you will be using mode 1. If it is 1 0, you will be using mode 2. If it is 1 1, you will be using mode 3. So for the given program, it is 0 1. That means it is mode 1. So from this we understand this. We are writing the program for timer 1 and mode 1 condition. So I hope you understood, right? So from this you can understand T mode is your mode selection register that for the timer. So 1 0 specify we are using timer 1 and mode 1. Okay. So now we want to load the value, that is a whatever value obtained here, that value you want to load in the register. Okay, so move, that is a label is again here we will be using. So the second instruction, move TL1 comma 0 0. So 0 0 is loaded in the TL1 and DC value is loaded in the TH. Now you can see that. So the lower byte hold 0 0 and higher byte hold DC. So now we loaded. Now timer is not started to count. To start the timer to count, what is the logic is I want to enable the TR bit. What is the TR? TR is a control bit. Okay, this is a bit you can find in the TCON register. So if you are specifying the TR is 1 only, your timer will start to count. So that's why in the fourth instruction I am setting the higher logic. Set B TR1. That means the TR1 will become 1. That means your timer is started to count DC01. So it will be keep on counting F. So during this transition, the timer flag will be 0. So first condition to start the timer, your TR is 1. Then only your timer will start to count. It will start to count from the loaded value, that is DC00. During this transition up to FFF, your flag will be 0. Once it reaches the roll off condition, your flag will become 1. Okay, that we will, this concept we need to write in the program. So you can see here JNB TF1. This is your timer flag. During the transition, during the counting, the timer flag is 0. What is a JNB jump? If bit is not set. So TF is 0. That means not set, right? Because TF is 0. Bit is not set. Where to jump? To back. So where to jump? To back. How many times you have to jump? From DC00 to FFFF. Up to that this condition will be satisfying. So it will be keep on rotating. Right. Once if roll off condition is occurs, that is the flag, timer flag will change from TF0 to TF1. So I am keep on monitoring the TF, that is the timer flag. Once the timer flag will change from 0 to 1, that means when once it reaches the roll off condition, right, I need to clear the your control register value, that is I want to clear the TR bit and TF bit. Okay, then I want to take a complement of whatever value holded in 2.3 pin, it should be, you want to take a complement. So let me say this is your port 2, this is your 2.3. So now currently it hold See, it started from DC00, it ends at FFF. That means it will provide the delay of 10 milliseconds. So let me say now it value is 0. So if you take a complement, it will go to higher logic. Okay, whatever that we don't know, maybe it can hold 1. If you consider this 1, you want to take a complement, means it will be 0. So now I consider 0. If you take a complement here, it will go to higher, right? Now then I'm going to the next instruction, short jump. Again I'm going here, and value will be loaded in the register, and it will start count. It will give the delay of 10 milliseconds up to here. Again the tr bit will set. Once the tr bit is set, your timer will start to count up to. It will keep on monitoring the timer flag. It will be in the loop up to tf is 0. Once the tf become 1, that is roll off condition is met, it comes out and it clear the tr and tf bit. Okay, then I want to take a complement. Okay, so again it will take a complement. So from it goes to 0. How much time? Up to 10 milliseconds. Here 10 milliseconds. So it will be keep on continuing. Okay, so this what is said in the program, right? So write a program to generate the square wave of 50 Hz frequency of pin 2.3. So in this question, the frequency was given. You want to calculate the time period. It is square wave. That means it is a this time period is for both on and off. So to find for individual pulse, for either for on or off, you want to divide by 2. So from there you want to find the what is the value, so that you have explained here, right? So that is 10 milliseconds divided by your machine cycle time. Then you find this value that should be converted into hexadecimal, that should be loaded in the timer register. From there only it will start the count. To start the count, so I repeat it again, it's very important. So what is the logic is, the first step is it is loaded in the th and tl register. Step 1. Step 2 is I want to start the timer. I want to start the timer, means your tr bit should be 1. Then it will start the timer to count. For every pulse it will start a count. So your loaded value is tg00. It will count up to fff. During this transition your flag will be 0. So it will keep on monitoring the flags. That's why this instruction does. When tf bit is become 1, it come outside from this loop and it clear the your control bit register values, that is tr1 and tf1, both will be clear. Then you want to take a complement. So if you, so the previous, you can assume anything. If it is 0, you want to consider as a 1. If it is 1, you want to take it as a 0. What is the delay? The delay is 10 milliseconds. Okay, this is a basic the logic will be this logic, like a first loading a register value, then set tr and monitoring the timer flag, then clearing the tr and tf. These steps are common in the all the timer programs. Okay, so now we will see the next program, just little small variation in this program. So what value do we need to load the timer register if you want to have a time delay of 5 milliseconds? In the previous program it was given frequency, but here I am giving 5 milliseconds. That means you are saying that you are on your period, that is on or off, it have the delay of 5 milliseconds. Okay, so show the program of timer 0 to create the pulse width of 5 milliseconds on port 2.7. Okay, that means from the, you have a port 2, that you have a range 0 to 7. In the 2.7 you want to generate the pulse. The width of the pulse is, the pulse width is 5 milliseconds. The pulse width is 5 milliseconds. Okay, what is the first procedure? First procedure, we want to divide by the time, that is a pulse width. Okay, that is a 5 milliseconds should be divided by your 1.085 microseconds. That is a machine cycle time. So if you divide, you will get the total clocks, that is 4608 clocks. So that you want to take a difference with the maximum pulse, right? Maximum clocks. So already I explained you everything. That is a 65536 minus 4608. How you got this 4608? 5 milliseconds for pulse width, that should be divided by 1.085 microseconds. Okay, so now value is loaded in the register. So now to start the timer, what I need to do, I want to enable the TR bit. Then the flag, your timer will start to count from the value of EE00 to FFFFF. During this transition, what is the timer flag? 0. Once it reach the maximum, it will reach the roll off condition, so the flag will become 1. So this is a basic algorithm we need to follow in the all the programs. Okay, now we will go for the program. So now you clear whatever data in the 2.3, the previous, that you just clear it. So clear 2.7. We know that in 2.7 only you want to generate the pulse width up to 5 milliseconds. That is from 2.7 only you want to generate the pulse with the width of 5 milliseconds. That is a program which is given for you. So in which mode you want to use? Mode 1 but timer 0. This is all given in the program. So if you write, now what is the second instruction? Now you want to say which mode and which timer. T mod is, you want to select the what type of mode you are using for the timer, so that I want to say. So that is 0 1. So 0 0 0 0 1 means 0 0 0 1. So this is timer 0. This is LSB 4 bits and this is where MSB 4 bits. Okay, if it is enabled in the LSB, that means it is timer 0. What type of mode? It is 0 1. That means it is mode 1. In the same place, if you have a 1 0, it is mode 2. If it is 1 1, it is mode 3. Okay, so in our case we are considering it is timer 0 and mode 1 operation. Now what is the value I have obtained? That is EE00. So 00 is loaded in the lower byte and EE is loaded in the higher byte. So here you have a 0, that means there is no more value. That's why to indicate only this 0 was given. Now you want to take a complement. So whatever there you cleared here, now you want to take a complement. Okay, so if you take a complement, whatever, if you have a 0, you will have a 1 now. Okay, so if you have a 0, it will be 1. So now we want to start your timer, right? So to start the timer, TR0, that means your TR, it will become 1. So what happened? It will give the delay of 5 milliseconds. Okay, so it starts from EE00 to FF. So it will be keep on monitoring the timer clock during this transition. So it's starting from EE00 to FFFFF. So during this, your timer flag will be 0. So the JNB, what it will do? Jump if bit is not set. So where I want to jump to, again it is given here, so it's keep on rotating. It will be inside this condition up to when tf0 equal to 0. When timer flag is become 1, when it go to the roll off condition, it will instruction fails and comes out. So once it comes out, I want to clear the tr bit and tf bit. Okay, here I please understand, here I want to generate only the pulse width. Okay, so that's why I'm in the starting itself I have taken the complement. Okay, in the previous case you can see, if there you want to generate the square wave, that is on and off. Here I want to generate only the pulse width of 5 milliseconds. So that's why I have taken the complement in the initial, in the before starting the timer itself I have taken the complement. Then you generate the pulse width of 5 milliseconds. Then after roll off, it comes out clearing the tr and tf. Short jump here, so again it will go to here, and again they load the value. So before it was 1, now I want to take a complement. What is the pulse width? 5 milliseconds, so it start from e00 to ffff. So again it keep on generating the pulse width like this. Okay, so this